Well, we're going to play with symbols because that's what algebra is all about. Which once you play with symbols, that allows you to come up with formulas. And once you have formulas, you have done before, you know that once you have formula, things just become pretty easy. You just plug in a number. But the algebra tells us like how to play those, how to get new formulas from existing formula. So for example, we all know that if you have a rectangle, this is the height, this is your base. Now your area is base times height, right?
Yep.
Okay, so now if you know the height in our base, you can calculate the area. But if you know the area and the base, then you'll be able to calculate the height, right?
Yep.
Or if you know the area and the height, then you'll be able to calculate the base, right?
Yep.
Because this is the equation. And so if there are three variables or there. So if we know the value of 2, then we can figure out the third. Good?
Okay.
So
Right.
from this formula, then we can derive 2 more formulas. Basically, what say the same thing, just we become the same relationship that way, but we are trying to find the different things based on what we know about the other 2 variables. Okay, so let's suppose if we know the area, this is known, and the base. Now, how do we came up with formula for the height? So what we do, because we have this, so what we're going to do is we're going to multiply 1 over b on both sides. Now, can we do that?
Yes. Sure.
Okay, remember we have a very fundamental rule for algebra is if a equal to b, then a times c equal to b times c. Remember that?
Mhm.
So, I mean, when you do algebra, I mean, the rules are just, we don't have that many rules. We just have a set of rules. And once we follow the rules, we're good. And the learning algebra is basically learning how to use that rule. Because once you are good with the rules, then you can do other things. You can, you know, come up with formulas that nobody has done that before, or you can prove a theorem that is maybe people are not aware of, or they just pretty useful. Okay, so we did that. We know we can do it. This is valid. So basically say if this is true, I mean, the whole algebra is the if then statement. This is a given, the relationship. So if this is true, then this has to be true. Now, if this has to be true, then we have the logic consequence. Then we know 1 over b times a is just a over b, right? Good.
Mhm.
And
Yeah.
this is basically h, b, and times 1 over b. Good.
Okay.
The reason we can do that, remember one of the rules is a times b is the same as b times a, right?
Yep.
Okay, so we have that. And then we know that b times 1 over b is 1. So therefore, what we have is a, b equal to h. And that we used this rule. This is called inverse rule or inverse property equal to 1. Good.
Okay.
So now we have a new formula, which that is if we know the area, if we know the base, then we can have a formula for finding the height. Good.
Okay.
Any questions so far?
Oh,
Nope.
we're
Okay. So, all right. I mean, this is basically the essence of algebra is to be able to play with the symbols. And so far, we don't have any number here, right?
Yep.
Everything is about symbols. But in order to play symbols, we have to follow the rules. And that's what we actually started with, the rules of algebra. So now we got to another formula. H is A over B. Okay. Now, what happens if we know the area and the height? We want to find the base. So it means we know this is a given. We know area, we know the height. We're trying to solve for B. Okay. So we can either based on this or that. Really doesn't matter which one to go with. So let's say we start based on that. So area is base times height. And by the way, this is basically this is our fundamental formula. Everything is derived based on that. Okay, we have that. And so we know we can times 1 over h on both sides. Good.
Yep.
And this is, again, it's from this property. If A equal to B, then A times C equal to B times C. So that's why we can do it. So as long as this is true, then this has to be true. Okay. And now 1 over h times A, that's basically A divided by h. On this side, we know h and 1 over h multiplies because a number times is reciprocal should give us 1 because we have that property there. Okay, so this is 1, then we got B. Actually, there's a B times 1, but we know a number times 1 is just number itself, so it just B itself. So therefore, we got the third formula. Good.
Okay.
Uh-huh.
Okay. So now with that, then with those 3 formulas, then we can solve anything that we are given. Just as long as we know two variables, we can solve for the third one. Good.
Okay.
Okay. So now I'm going to give you exercise based on this. All right. So you know that speed.
What?
Speed is distance over time, right?
Yep.
Huh?
Are we good on here?
Yes.
Yes.
So this pretty much is the definition. Speed is the distance over time. And we're actually talking about average speed. And there is actually a special symbol like that, which means this is a definition, okay? If it's definition, we don't have to prove it, right?
Right.
Huh.
Have you heard of the term by definition?
Term what?
Or maybe the clause is by definition, this is true,
Yeah. I've heard that.
right?
Maybe-
When we say something is by definition, that means that's given. I mean, we don't have to prove it because that's just what we mean by that. Good. So-
Okay.
So the average speed is defined as a distance over time, right?
Uh-huh.
So like you have that doesn't matter if you have a car or bicycle, like say if you have a bicycle and you go cross a distance, let's say we use D as distance, and you actually calculate the time. I mean, this is your beginning of time. Let's say this is your 10:15 in the morning, and you cover the distance. let's say you cover 2 miles. And you check your watch again. This is 10, like say 30. Yeah. Okay. That means the time you spend on is 15 minutes, right?
Mhm.
So then the speed is the mile, 2 miles over 15 minutes. Good.
Yep.
And that give us so 2 over 15. Let's see what's that. 2 divided by 15. Oh, it's a 0.133, and that it's just like mile per minute. Good.
Okay.
And sometimes we want to know mile per hour. So what we're going to do is, if you want to know mile per hour, is basically we just times 60 minutes on that, right? Because this
Okay.
is a mile per minute. So in order to find mile per hour, I mean, each hour is just 60 minutes. So we
Mhm.
times 60. We got basically, in this case, actually it's 8 miles per hour. Okay, so it's kind of decent, right?
Yeah.
So when you take a bike ride, have you ever measured your speed?
Mm, no, I haven't.
No. Okay.
I do, and I think I've gone like, well, I think my top speed is like 40 miles per hour.
40 miles per hour.
Yeah,
Pretty
I
fast
got
on a bike.
so I go with like a very large gear to a very small gear, and I pedal as fast as I possibly can.
I know, this is amazing. 45 per hour. You got going as fast as a car on the city street.
Yeah.
That's pretty fast. That is.
Should deliver mail or something.
Yeah. Okay. So now we know that we have that. Then, and we go say, okay, the speed is defined at distance over time. But if we know the distance and we know the speed, can we figure out the time?
Yes.
Yeah.
Yep. Because here we have equation. We got 3 variables. As long as we know 2, then we can figure out the third, right?
Mhm.
Because that gives us a relationship. So now, can you come up a formula for time, knowing the speed and the distance? And sometimes, actually, in physics, they like to use this as, instead of s, you like a v as velocity, because because s sometimes you use s for distance, so it could get confused. And yeah, but it's really up to us. Whatever symbol we want to use, it's just a symbol. Okay, let's say we use v. Now this exercise for you, based on what we did here. Remember how we did that? Came up with the other 2 formula. One is for time, and one is for distance.
Okay.
So would you have to multiply distances reciprocal by itself and velocities by distances reciprocal?
Yeah, you can time the reciprocal of distance on both sides.
Okay. So.
And tell you what, you find this first, and you'll see that make things a lot easier. Find the distance formula first.
Okay.
So it doesn't matter what you're going to do. I mean, as long as you play with the rule, okay?
Okay.
So basically, in this case, we want to keep D on the left. Everything goes to the right, right? That's our goal. So however you accomplish goal is really up to you. And that's So it's just kind of like you play a game. As long as you follow the rules, I mean, you can do whatever you want. Sometimes you can be quite innovative. Yeah. I mean,
Okay.
you think about soccer, right? At the first, when they started playing soccer, they probably never thought of using their head. It's just like while they're playing, someone figure out, oh, I can use my head, and they're still within the rule, and so therefore, okay, everybody is copying it. Yeah, and there are a lot of like moves in the soccer, which is actually quite innovative. At the beginning, they probably don't have that kind of move, not technique, but people can develop a technique. But as long as you follow the rule, right, you cannot touch with your hand. You cannot actually touch your arm cannot even touch the ball. You can, I mean, then after that, I mean, any other part is fine. You can use your head, you can use your chest, you know, you can use whatever part of your body. But as long as you follow the rule, you can just play with it. So that's kind of nice thing about algebra. It's actually kind of fun once you know how to play the symbols, but still following the rules. Okay. Anyone came up with a distance formula?
No, not me.
Okay, I'll show you what. You can do this first, because we are going to have the d on the left, the distance. So we have this. Okay, so how do you get rid of t on the left-hand side?
Well, you would multiply it by probably its reciprocal or its opposite.
It's a reciprocal. What is the reciprocal of 1 over t?
T over 1?
Right, t over 1 just t, right?
Yep.
So we multiply t on both sides. Then what we have on our left-hand side?
D.
T and t cancel, right?
You just have d.
So d then is v times t, right?
Oh, that's interesting.
Right. So then the distance then is velocity times the time. Good.
Okay.
Wow.
It's more simple than what I imagined it would be.
Oh yeah, it's actually, yeah, you see that actually in, especially when you're learning physics. Physics actually, for the most part, is just based on 3 laws, Newton's 3 laws. Then you just play with the symbols.
Okay.
Okay. So once you have distance formula, can you come up with a time formula?
Well, I think time would probably be about the same thing, only with different symbols. Like,
Right. So you keep, well, same thing. Like the first thing, I mean, you don't have to do this, but that's how I do it. I just keep now I'm going to based on this formula. You can use based on that. Okay, I'm going to show you on both how to do that. One is that I can just use this because we just prove it. This is true.
Mhm.
So therefore we can use it. We know this is the same as Vt equal to d. And now in order to isolate t, I just need to get rid of v, right? So
Okay.
how do I get rid of v?
probably like with the other one, like multiply it by its reciprocal, or maybe its opposite.
Multiply by reciprocal.
Okay.
Okay, when you multiply, always reciprocal. When you
Oh.
add, that's where you add the opposite.
Oh, okay. I think I might have
Good.
gotten mixed up there.
Yep. Okay, we have that, right? So what is 1v times v then?
That would just be v, or just 1.
1. Then 1 times t, just t, right?
Mhm.
That's what I mean by canceling, is to cancel. The way, basically, I mean, the canceling is actually not not a technically correct, accurate. It's just basically because a 1v over times v become 1, so we get rid of the symbol. Okay, so we have T on this side. How about on the right hand side? D
We
times 1 over V, that's just D over V, right?
D over V.
Yep.
Oh, be D over V.
So therefore, our finding the time is distance over the speed. Good,
Okay.
Got it. I got a question.
sure.
So if you wanted to calculate the speed of your bike,
Mm-hmm,
could you? So the way you could find like your speed,
mm-hmm.
could you like find out, use pi to find like the distance around your tire rim, and then divide mile per hour by that?
Ah, okay. So that is good idea. Good question. Say if you have a tire, right?
Huh?
And that's actually how they measure speed. So they measure how many turns of that. Good.
Okay.
So you basically you can put a sensor somewhere to check. Just measure the turn. Good.
Okay.
Now we know that each turn will cover 2 pi r, right? Good.
Yep.
Yeah.
So as long as we can measure the turn, let's say we spend maybe 10 minutes because you know you need to have time. Normally you take longer to average out to be more accurate. Okay, 10 minutes and you find how many turns you have. Let's say you got 1,000 turns. Good.
Uh-huh.
So the distance then is 1,000 turn times the circumference of your wheel. Good.
Okay.
And then you just the distance, that's 1,000 times 2 pi r over the time, and that will give you whatever. Also, this one is kind of interesting, is the unit when you're doing thing. So normally unit is probably is in terms of feet or inch. Good.
Okay.
Now, if we use an inch, what we calculated is inch, they call inch per minute. Good.
All right.
But once we know that, we can change that to miles per hour or change that to inch per second or even meter per second. Good.
Okay.
Okay. So now we actually get back to a couple questions. Let's say now Jade, you
Mhm.
take a bike ride, okay?
Yeah.
You did like say 10 minutes.
Mhm.
And your speed is let's say just a little bit slower this time.
Yeah.
How about 35 miles per hour?
Mhm.
Miles per hour. Okay. Now, what is the distance you cover? Remember, we just did the formula, right?
Okay, so
The formula is
let's see, I had copied it down. Is it D times V times D is equal to V times T?
right. So the distance is the speed times the time, right?
Uh-huh.
So therefore, it should be 35 minutes. That's our speed, right?
35. Yeah, 35 miles.
That's mile per hour. But this is per hour. This is a minute. So we have to change that to in terms of hour, right?
Okay, so
So that is 10 over 60, right?
yeah.
And so that means you got 35. I mean, this 0, 0 can. So 35 over 6. And that is 35 divided by 6 is what? 5. So it's 5 over 6, right?
Mhm.
So that's our distance. So we did about close to like 6 miles. Good.
Okay.
Uh-huh.
Make sense?
Yeah.
Actually
Oh.
does.
Okay. Last one. Let's say Jade spent 50 minutes and he did 20 miles per hour. What's the distance?
H. So distance is equal to v velocity.
Yep.
Times
So got 20 miles per hour, multiply.
n.
So times time, but we have to change this to hour because this is hour. Our unit is hour. So unit has to match.
Okay, so divide 10 over 60.
15 over 60, right?
Yep.
And we can simplify that. Let's say let's divide by 5. Divide by 3. This is 5. This is 20, right?
Mhm.
Now 20 and 20 can cancel, so we got 5 miles.
Ooh,
Good.
Yep.
Yeah.
Okay. So this is what we have for today, and next week we can continue that, but we're going to look into other applications. Okay. So basically, it help you to become confident at playing symbols. Good.
All right.
All right. So I'll see you next time.
Okay. Bye.
Bye.
Thank you.
You're welcome.